Energy and Atmosphere, LEED version 3, 2009. Energy and Atmosphere is the most heavily weighted category in the LEED version 3 rating system. As you see here, there are 3 prerequisites, each mandatory for any LEED building to achieve: fundamental commissioning, minimum energy performance, and fundamental refrigerant management. And each one of those has a credit that builds on that baseline. For example, optimized energy performance builds on the minimum energy performance requirements, both referencing ASHRAE 90.1, as we'll look at. Minimum energy performance, though, because it's prerequisite, does not give you any points. It's just a requirement. Whereas EA Credit 1, Optimized Energy Performance, has 1 to 19 points associated with it, depending on how much more efficient your building is than that ASHRAE 90.1 baseline. It is the most heavily weighted credit in the LEED rating system because it's seen to make the biggest impact on both environmental impacts, climate change, and cost savings. Enhanced Commissioning, EA Credit 3, builds on the fundamental commissioning of building energy systems, EA Prerequisite 1, and we'll compare that as we look deeper into the credits themselves. What you see in orange are the more heavily weighted credits. Here are a few more credits. Gets into measurement and verification, which is one of the only LEED new construction credits that actually involves work later on in the process with 1 year of verification. And green power, which is off-site renewable energy. We'll delve into each one of these credits. There are 3 main concepts that I look at this section for, and that is commissioning, energy, and refrigerants. So in a section that has so many credits and points associated with it, it's good to start to realize the kind of synergies between them and how they interrelate. So for commissioning, you have EA Prerequisite 1, Fundamental Commissioning, EA Credit 3, Enhanced Commissioning, but also EA Credit 5, Measurement and Verification, which includes the same type of trending and optimizing of equipment that has to do with commissioning. Energy efficiency includes a prerequisite, minimum energy performance. Also, the optimized energy performance that has 1 to 19 points associated with it. And also renewable energy for EA Credit 2, on-site renewable energy, and EA Credit 6, green power, which is about off-site renewable energy production. Refrigerants is the third concept that I categorize this section in. And it has a fundamental refrigerant management and enhanced refrigerant management credit associated with it. And this has to do with global warming potential and ozone depletion potential. So those are the 3 main concepts to keep in mind when going through this section. Commissioning. You do have to know terminology for the test. Commissioning is an important concept to understand. It is the process of verifying and documenting that the facility and all of its systems and assemblies are planned, designed, installed, tested, operated, and maintained to meet the owner's project requirements. CXA stands for Commissioning Agent, which does need to be associated with each project. If you're going for fundamental commissioning, there are different requirements than getting points for the credit for enhanced commissioning. But there does need to be a commissioning agent assigned to every LEED project. EA Prerequisite 1, Fundamental Commissioning, is required for every LEED project. Minimum required commission systems are the HVAC and refrigerant systems, lighting and daylighting controls, domestic hot water systems, and renewable energy systems if they're applied. Additional systems to consider but are not required in the prerequisite are water using systems, stormwater management, especially if you're dealing with smart controls or rainwater harvesting or gray water reuse. It's important to make sure that all those systems are commissioned so they are operating as they're intended to be and installed correctly. You also should take into consideration information technology systems, and this could include a DDC system or other integrated systems or controls. Building envelope systems, this could be automatic sensors for daylighting or for shades, many other systems. It's important to compare to the owner's project requirements, OPR, which is the first thing that's considered in the fundamental commissioning process. The benefits of fundamental commissioning are optimized mechanical and electrical and architectural systems. There's life cycle savings, which can reduce the soft costs associated with it. Those operational cost savings can be 5 to 10% of your annual energy use. And in the construction process, it can improve building documentation. Since drawings are reviewed and the team has to carefully look at all the systems being applied. This way it also improves coordination and reduces change orders. It relates to many other credits because you are actually verifying systems. You need to appoint a commissioning agent to start the process and ensure they can complete 6 required tasks. First being establishing and reviewing the owner's project requirements, known as the OPR. This is when the owner sets their goals and expectations, which is important for the whole team to understand and helps with communication. It should be what's referred back to throughout the design process. Then a basis of design needs to be established, known as the BOD. This is often done by the mechanical team and needs to be updated as there are changes to the design. Then there's a commissioning plan, how it's going to be executed. Commissioning specifications start to fine-tune the systems themselves. And there's performance verification documentation involving things like functional testing, and then ultimately a commissioning report on how the systems were actually performing. Owner's project requirements is a written document that details the functional requirements. So includes owner and user requirements, environmental and sustainability goals, indoor environmental quality requirements, equipment and system expectations, building occupant and operations and maintenance personnel requirements. Basis of design, as mentioned, is developed by the design team and updated as design modifications are made to accomplish the owner's project requirements. So you can see how things are intertwined with each other. It includes a primary design assumption section, standards to refer to, and narrative descriptions of the equipment. The commissioning specification is the contract document that details the commissioning requirements to the contractors. This is a very important link between the design team and the contractors on site. Integrated project delivery encourages this to be done on many levels. It needs to include a commissioning review and requirements to be integrated into the construction documents. And commission requirements are typically outlined in one section of the general conditions of the construction specifications. Although it's important that all sections refer back to this commissioning section, so it's not isolated. Subcontractors also have to be aware of these requirements since it does affect many of their systems being incorporated into the building. Commissioning plan. Identify strategies and responsibilities within the commissioning process for each phase of a project for all the team members. You should include commissioning program overview, commissioning team, and a description of commissioning process activities. Verifying installation and performance of systems includes installation inspection, systems performing testing, and evaluation of results compared to the owner's project requirements and basis of design. Want to complete a summary, which is the commissioning report. This is done upon completion of installation, inspections, and performance verification. The results are assembled to document the commissioning process, including the as-built performance of the HVAC system and unresolved issues. You want to include executive summary of process and results, a history of system deficiencies, and systems performance test results and evaluation. The second prerequisite is minimum energy performance. There are multiple options to show compliance. The first option is whole building simulation, which is the most beneficial for optimizing points in EA Credit 1 as well. And this is actually building an energy model and comparing it against a baseline case referring to standard ASHRAE Standard 90.1, 2007. In version 4, it'll be a newer standard of ASHRAE most likely. You can also use more stringent state energy codes such as California Title 24. For schools, you can use the EPA's Target Finder rating tool for a baseline as well. Newly required in LEED version 3 was a minimum energy efficiency rating improvement of 10% for new buildings and 5% for major renovations, keeping in mind that LEED new construction also includes major renovations, and there are slight changes to some credits for major renovations. For core and shell projects, you only include provisions within the core and shell scope, since the owner-developer is not in control of all TI and construction design processes within the building beyond the core and shell. The proposed design must meet all requirements of ASHRAE 90.1 sections 5.4, 6.4, 7.4, 8.4, 9.4, and 10.4. You need to include all energy costs associated with the building, since it is based on energy cost calculations. And then compare it back to the baseline building that complies with Appendix G of Standard 90.1. That's a critical standard to remember. Appendix G of Standard 90.1 for your energy baseline. This is important for the test. The LEED rating system does allow you to use default values for things that are difficult to assess before the building is in full operation. Process energy is one of those things. If you are unsure of actual energy costs of your process energy, you can use the default cost of 25% of the total energy cost for the baseline building. And this is when it's hard to predict how much office equipment, computers, elevators, kitchen cooking, refrigeration, and laundry are going to actually be utilized in your building. For buildings such as industrial manufacturing buildings, you may want to incorporate process load in its actual amounts because it is the majority of your energy use. And then you need to carefully go through the process of setting those baselines based on national standards. It's an important thing to discuss in early design for those types of buildings. There are more and more case studies coming up. At EcoReal, we're currently working on a brewery and a plastics manufacturing company. And for each one of those, we're having to assess the individual equipment with the team to come up with those baselines beyond ASHRAE 90.1. Option 2, for new construction and core and shell projects only. It's a prescriptive compliance path, meaning you don't have an energy model. You utilize the ASHRAE Advanced Energy Design Guide. Path 1 is the ASHRAE Advanced Energy Design Guide for small office buildings. Path 2 is for retail buildings. And Path 3 is for small warehouses and self-storage buildings. So depending on your building type, you'll select which ASHRAE Energy Design Guide fits most appropriately. Option 2 is for schools only. This is the prescriptive path using the Advanced Energy Design Guide for K through 12 school buildings. I recommend downloading these standards as a reference when working on LEED or any green building projects. Even if an energy model is built, it's important to have these guidelines for reference points of how to design and construct energy efficient buildings. ASHRAE also has a new standard 189.1 that's very helpful as a design guide. Also use the Collaborative for High Performance Schools as a reference. In order to use option 2, the schools must be less than 200,000 square feet. Option 3 applies to all building types except for healthcare, warehouses, and laboratories. They must be smaller than 100,000 square feet. If you meet this criteria, the standard is the Advanced Building Core Performance Guide. You must meet Section 1, Design Process Strategies, and Section 2, Core Performance Requirements. Types of buildings that typically comply are office, school, public assembly, or retail. Documentation included is list any ASHRAE addenda used and copies of the forms. Determine the climate zone for the project location. If you have the reference guide, you can refer to page 243. And it has a table. This is how the reference manual is a helpful guide when you're actually implementing this on a project, because you do want to design per your bioregion. At that point, you can calculate the energy use by type and keep a list of the end energy use for the project building. And the important standard to remember is ASHRAE 90.1 2007 Appendix G. That's what you use as your baseline for your computer simulation. And for the prescriptive compliance path, you need to assemble required documentation per the ASHRAE standards in those design guides. The benefits associated with this prerequisite are energy efficiency, reduces in the air and water pollution, land degradation, solid waste generation, and greenhouse gas emissions, your overall carbon footprint. And something owners, operators appreciate are reduction in overall operating costs. There are many related credits that have synergies with this credit as well, since energy efficiency is really an aggregate total of how efficient your building was in water usage, site lighting's related, and also renewable energy, as we'll see. Here's a snapshot of what the Core Performance Guide Enhanced Performance Strategies looks like. You don't have to memorize this, but it's important to be familiar with these categories. You can see some mandatory measures include building envelope compliance documentation, HVAC compliance documentation, surface water heating, and lighting compliance.